Okay. So, give me a second. My voice is stable, right? All of you. I'm audible, right?
Yes. Yes, you are audible.
So today we will discuss about Kubernetes. Okay, this is one of the major topic that comes under the DevOps. Kubernetes. Right. For the newcomers, anyone heard about Kubernetes and why we use Kubernetes? What are the scenarios that we follow Kubernetes infrastructure? Any idea?
This is advanced level than Docker.
Yes.
And also we can create pods here,
Okay.
image generation. Yeah, that's it. I know that's it.
Okay. Image generation. I don't think so. Image generation. We need to generate the image, right? You mean Docker image, right?
Yeah, yes, sir.
We can't use Kubernetes to generate image. We need to use Docker to build image. Okay. After that, we will
Okay, sir.
push the image to Docker Hub. Then we will pull that image using Kubernetes. Yeah, manifest.
Okay, sir. Okay, sir.
Okay. So coming to Kubernetes, what is Kubernetes? Okay. So basically, it's a container orchestrator. Okay. That means like when coming to Docker environment, okay, when coming to Docker environment, for example, we deployed some applications, okay, some microservice application using Docker. There is no container there. Sorry, no Kubernetes scenario. This is only for the Docker. So,
are you on a different screen?
No, I mean Paint. I'm
Oh, okay.
Paint. Yeah, you can see my Paint screen. Paint screen, right?
Yes.
Okay. So the requirement is uh, deploy some applications. Okay. This is a scenario. So we use Docker. Okay. Our environment is Docker. This is before Kubernetes. Okay. I'm talking about before Kubernetes. So what will we do? We build image, or first we need to create the Docker file. Then we need to build. Then after we need to run the image, right? After running, we will get containers, right? So container one, container two. Okay, container two. So in previous section, we created similar like this. Okay. So coming to production environment, there is no two container. Okay, because we need to deploy a lot of services, microservices using different containers. So coming to production, for a single application, I think 30 containers, 40 containers, or 100 containers like that, as per the application scenario. Okay. For example, we can take a application, test application, test app. So that applications have like 40 microservices. Okay, like small services for this application. 40 services. So 40 services, we need to create 40 container. So container 2, 3, container 4, like container 40. So managing Docker container is sometimes is a messy thing, because we can handle at least 20 below 20 containers is fine. I think as a human being we can manage, because these containers sometimes having some issues, or sometimes it will go stop or down state or fail state. So we need to go to troubleshoot that specific container, and we need to get back that online. Okay. So similar scenario we need to perform when we working with the Docker container. So 20 containers or below 20 containers, we can easily manage. So coming to production, there is lot of containers like 40, 50, 100 or 200, like that container we need to deploy and we need to manage. So that is not a good thing that we, as a human being, we can't manage. Okay. Like, because these containers have some issues in real time environment. So we need some tool or some other service to manage these containers, okay, or to orchestrate these containers. So there, the Kubernetes comes. So coming to Kubernetes, we use Kubernetes as an orchestrator to manage the application containers. So we didn't bother about these manually. For example, if coming to Docker, sometimes any container is failed or it's going to exit state. Okay, so what we'll do, we need to go to the container and we need to troubleshoot the issues, and we need to back to online the container. Okay, so there is a lot of time to spend. We need to spend to get back online this special container. So coming to Kubernetes, we didn't go to do this scenario, because Kubernetes have its own ability to manage containers and healings. For example, if any container is down under the Kubernetes, then the Kubernetes will manage, or Kubernetes will restart the container. And the Kubernetes service can do the entire things. Okay, so we didn't bother about the container and runtime issue or anything. Coming to Kubernetes, got it. So coming to Kubernetes, say open source platform used for automating the deployment, scaling, and management of containerized application. So it's automating these processes like deployment, scaling, and management of containerized application. Kubernetes is developed by Google. Actually, it's a Google now it's maintained by Cloud Native Computing Foundation. So before Google developers developed the Kubernetes. So coming to the features, okay, key features of Kubernetes. The first feature is automated scheduling. So the Kubernetes automatically schedules containers across nodes in a cluster based on resources, requirement, and constraints. Okay. Then self-healing. This is one of the feature of Kubernetes, self-healing. So Kubernetes monitoring the health of node and container. If any container fails, Kubernetes will automatically restart or replace it. And unhealthy nodes are automatically removed and new nodes can be added as needed. Then the next feature, like horizontal scaling. It's a scaling process, okay? So Kubernetes allows for easy scaling of application up or down. Containers can be scaled based on CPU, memory usage, or we can use custom metrics as well, okay? So it allows application to handle changes in load dynamically. Then coming to load balancer, Kubernetes provide built-in service discovery and load balancing. Okay, it's assigned that DNS names to service and can distribute traffic between containers. So that will ensuring high availability of our application too. Then rollback and rollout. Okay, this is coming to Kubernetes. It's automated the rollout and rollback service. So Kubernetes automated rolling or it support automated rolling update for application, allowing updates to deploying without downtime. So sometimes it goes wrong, it can automatically roll back. So we can easily roll back to the previous state of the application or previous stable state. So coming to the environment, okay, because it's a multi-cloud or hybrid cloud support coming to Kubernetes. So Kubernetes can run in various environments, including like on-premise or public cloud like AWS, GCP, or Azure, and we can set up hybrid setup as well. Okay, so we can say it's flexible and portable. Kubernetes is flexible and highly portable. So these are the common features of Kubernetes. Then coming to the architecture, okay, we need to learn the architecture of Kubernetes. So this is the Kubernetes architecture, okay. So coming to Kubernetes have two part. One is master part and worker part. So, so this is the master part, okay. Master, and this part is called worker. So we called the entire part as Kubernetes cluster. Kubernetes cluster. Okay. So coming to master part, the master part has some components. There is four components. Okay, four components are there. So I just bracketing that thing. 4 components coming to master part and coming to worker part. What are things like node? One, two, three components are there. Okay, because actually some components are within the node. Okay, so I will explain. So the first component is API server or API. Then etcd controller and scheduler. So these are the components or services that comes under the Kubernetes master part. Okay. So we need to learn this architecture and the components coming to Kubernetes. And sometimes we face interview questions like explain the Kubernetes architecture or the workflow. So we need to explain the architecture with the components and its specifications. Okay. So coming to worker part. Okay. Now we are in the master part. So like Kubernetes have two parts. One is work master and one is worker. So coming to worker, some components are there. So yes, coming to worker part, the components we called as nodes. Node. So here we can see node 1, node 2, and node 3. So what is node actually? It's simple. Uh, we can call it as coming to the yes, we can call it as Ritesh Singh EC2 or the machines, okay, that we configured within the Kubernetes cluster. So what is node? Node, it's same as EC2 virtual machines. So here coming to node. Node is equal to EC2 VM. Okay. So coming to the worker part, we configure. This is in a AWS scenario. Okay. So we didn't configure because the Kubernetes will configure 3 EC2 machines for this Kubernetes. That means after deploying the Kubernetes cluster, we will get a master part and a worker part with 3 EC2 machines or 3 node. Got it. So in this case, we have EC2 1, EC2 2, EC2 1, 2, and EC2 3. So we have 3 machines for running our Kubernetes applications. Got it. Anyone have any doubt? All good, right? All of you.
Yeah.
Okay. So yes, so we you know how what is the node? Okay, so it's simply a EC2 machine. Then coming to node, okay, coming to a single node, some other components like okay. So coming to EC2 machine, okay, coming to a single node, there is some other components are there, like we called as node. So this is a sorry, this is pod. We called as pod, okay, coming to node. So this is a pod. So this is pod 1, and here we can see one more pod there, pod 2. Here as well, pod 1, P1, and P2. Here, P1 only, okay. So what is pod? Okay, I will explain one more thing. Coming to pod, okay. Coming to pod, this is our actual container. So this is a container 1. Inside the container, okay, this containers actually these containers hold the applications. So we can say this is the application. So similar way here as well, like application container we running container. That's all. This is another instances of application. Okay, application coming to here. There is a container running C, and inside the container application. Similar way to each pods. Okay, so pod is actually a smallest deployment unit within a Kubernetes container, as Kubernetes or cluster. So why we use pod? Because the master part can't directly communicate with the containers. So here we created another service called a pod. So within the pod we created or the Kubernetes deploy the application container. Got it. So some other components, two components we missed here. That is that components runs inside our virtual machines or that node. So two things are there. One is kube proxy and kubelet. So each machines or each nodes have same services or the components. That is the first one is kubelet. Kubelet and kube proxy. Kube proxy. So similar way in each container, each node have same components like kubelet and kube proxy. Kubelet and kube proxy. Here as well. Kube proxy. So what is kube proxy? Kubeproxy is like a agent, okay, that pre-installed within each node when it's deployed. So kubelet is a agent. That agent communicate with the master part or the kube API server. Okay, so there is a communication between this master part and the worker part. So that's happened via kubelet. So the kubelet continuously monitoring uh, s- s- uh, this machine. Okay, this node status. That's I mean CPU status, memory status, how many resources that that the node have, and how what are the containers running, how many ports running inside the node. Everything is monitoring or everything is logged via kubelet. So kubelet monitoring all the things and set the logs to master part. So these are the Kubernetes components, key components that work together to manage containerized application across a cluster of machines. So these components are categorized into control plane, that is master part, and node components, that's the worker part. Okay. So coming to the master part or the control plane components, the first thing is API server or Kube API server. This is a API server act as the front end for the Kubernetes control plane, and it handles all communication between the components and provide the central interface for the management tool. Got it? So that is a API server. So coming to etcd, the next component of master part. etcd is actually a distributed key value store that act as a Kubernetes backend storage for all cluster data. It's similar like a small key value pair database. So it stores the entire state of the cluster, including configuration, status of the node, and the status of the workload. Everything is saved in the etcd database. It's a small key value pair database. Okay, so it's storing these Kubernetes data. Then the controller, we called as control manager or kube control manager. So this component is responsible for managing the various controllers in the Kubernetes cluster. Okay, Kubernetes cluster that ensure the desired state of the system. For example, monitoring node health. So the node controller are there. Okay, so it will monitoring the node health. Then like replication controller ensure the correct number of pods are running. So it will like ensure these things like replications of controller. Then manage services and pod endpoints. Then manage service accounts and access tokens. These are the things that the control manager doing. Okay, when coming to master part. Then the scheduler. Scheduler is a simple thing, simple service. Okay. So scheduler assign workloads, that is pods. So the scheduler assign pods to node in the cluster based on the availability of resources like node health, workload requirement, then affinity, anti-affinity rules. Some rules are there, okay, coming to the Kubernetes. So the scheduler assign the pods based on these resources, available resources. So these are the like high level overview of these components within the master part. So coming to the worker part, okay, or the node components part. So here we can see the components like kubelet and kubeproxy. So the kubelet is a agent that runs on each node in the cluster. So the agent ensure that containers are running in a pod as defined in the pod spec. or the manifest. Okay, we need to create some YAML file for deploying our application to Kubernetes. So that means the pod specification. Okay, so the kubelet ensure the containers are running in a pod as defined in the pod spec from the API server. It's communicate with the control plane and it's responsible for launching and monitoring containers. Then the next components in worker part is kubeproxy. Kubeproxy is a network proxy that runs on each node to manage Kubernetes networking rules. It handles routing traffic from external source to appropriate pod or services and manage internal traffic between services too. So one more service I missed, that container runtime. Okay, because coming to Kubernetes, we need to specify the correct container runtime. Container runtime in the sense of like Docker or which container that we implement within our Kubernetes cluster. So container runtime is underlying the software responsible for running containers on node. So the Kubernetes support different container runtime such as Docker, Container D, or CRIO, etc. Container D. So the Container D comes node. Okay. So I just explain like this. Container D. This is a runtime container. Okay. Which runtime that we follow with the corresponding Kubernetes cluster. So these are the architecture and the overview of Kubernetes. So anyone have any doubt?
Sir, will you be sharing a text document of these things? Because looks like there are too many things to remember.
Yeah, I will share the documentation.
Okay, thank you.
So anyone have any doubt?
No doubt.
Okay. So coming to the implementation or configuration of Kubernetes, we within a single command. Okay, within a single command, we can provisioning, or we can installing the Kubernetes cluster. Okay, so so after that we will get the master part and the worker part. Okay, not the pod or anything, application or anything. We can see the master part is running there and the worker part with the 3 node we can see using commands. So after that, that means we installed a Kubernetes from scratch. Okay, so after we can see the how many node that running in the Kubernetes we can see using there are some commands there. Okay, we need to learn some Kubernetes commands there, similar like Docker commands. So like okay, this is a cluster. Okay, so consider like or just assume that we deployed a Kubernetes cluster. Okay, so that after that we need to manage as a DevOps engineer. We need to manage the Kubernetes cluster. Okay, so we have a laptop. This is our laptop. So how we will manage or like deploy applications or manage the cluster via the API server. Okay, so that before that we need to install a command line tool. That command line tool interact with our Kubernetes cluster. So there is a command line tool there. That name is kubectl. This is a service or a application. So that we need to install in our local machine. So this is our laptop. So after configuring this Kubernetes cluster, the next thing is we need to install kubectl in our local machine. So we can go to the kubectl package using Google. So we can download the package and install in our laptop. So after that, we install kubectl. Then using the kubectl command line tool, we can connect with our Kubernetes cluster. So before that, we need to provide the credentials or the configurations of Kubernetes and saved in our laptop, okay, or local machine. Then we can use kubectl command to manage our Kubernetes cluster. So there are some commands, Kubernetes commands that we need to learn. Kubectl get node. So this is one of the command we use for how many node in our Kubernetes cluster. So it will list these 3 node, and we can see the output, okay, in the same local machine command line, or where we using the kubectl in our laptop or local machine. So similar commands are there. So all commands start with the kubectl. Kubectl get node. So it will list the how many nodes are in our Kubernetes cluster. So instead of node, we can put pod, okay, kubectl get pod. So how many pods are running in our cluster, it will list here. So everything we can list like this using kubectl commands. Okay. So just consider we successfully installed a Kubernetes cluster. Okay. So that means we have 3 pod with the components. Not created any pod or application there by default. So we need to create our applications or pod and node. So okay. So this way a new cluster looks like, okay, the master part and the worker part with these components. Okay, there is no pod or no applications running or no content. Okay, so how we will deploy application? Okay, so this is like the newly deployed Kubernetes cluster. Okay, so how we will deploy application? For that, we need to create a file. So that file, we need to create a YAML file. Okay, because when coming to Kubernetes, we will create, or we need to create some YAML files. That is called a Kubernetes manifest. Okay, so what is a YAML file? YAML file contains the application configurations, application name, applications like service name, application image name, everything is listed inside the YAML file. Okay, so there is a file. That file actually belongs to our local machines. For example, we have a laptop. Here we have our laptop there. Okay, so laptop, we already installed the kubectl, so we can connect with our Kubernetes cluster. Okay, remotely we have the access to manage the Kubernetes cluster, or we can deploy application to the cluster. So that permission we have. After that, we need to create a YAML file. Okay, for example, application.yaml. This is our application YAML file. So coming to the YAML file, okay, this is a console, this is a file, YAML. So here we need to provide the details of the application specification, configuration, the image that we use. Image means the Docker image. So everything we need to specify inside the YAML file. After that, we will push the file. Okay, as of now, the file belongs to this local laptop. Okay, so we need to push the file to the Kubernetes cluster so that the cluster deploying that YAML file. So what are the configuration that we specify in the YAML file? So the Kubernetes knows each thing. So it will move into the other components and it will push to the pods. I mean the worker node. Okay. So for example, here we already specified that how many pod that we or how many uh, container that we need to create for the specific application. So it is two. Okay, we mentioned that as it's two. Okay, two means uh, the application instance of it. For example, we need to create two application, similar application, identical application. One application is down, that the second application is running successfully. So that we can use a replicas when coming to Kubernetes. We called as replicas. How many replications of same application? So here we need to mention two. So after pushing, okay, using kubectl command, we can push the code or push the YAML file to the Kubernetes cluster through how the communication happen. It's like through the API server. Okay, so we pushing the YAML file. So API server take over that YAML file and go through the components. After that, it will deploy the scheduler everything and just deploy to our worker part. That means the EC2 machine. So here we mentioned two replicas. That means it will create two pod 1 and pod 2, and inside pod create two containers. One container in first pod P1 and this is a P2. So second containers comes under the P2. So both container having the same application. Got it. So this way the application deployment happen. For example, the P2, the second containers might be go to the second node. Okay. These all things managed by the master part. We didn't bother that. So sometimes the P2 or the pod 2 goes to second node and container running inside here. This is not belongs to the second pod node belongs to the first node. For example, here the replicas 2 instead of 2 it's 4, then it's shared like the schedulers know which node is healthy to receiving the pod. So based on the requirement, some pods goes to the corresponding node. Good. This is a simple scenario of the application deployment that perform in Kubernetes. So we need a YAML file for the deployment, and we push the YAML file from the local machine to the Kubernetes cluster. So anyone have any doubt? All of you. So coming to the lab, okay. Coming to lab, you will get more idea or clarification how these things works. All of you.
Yeah.
Yes, sir.
Okay. So I will show you a simple YAML file. Give me a second. So my screen is visible, right?
Yes.
So this is a simple YAML file to deploy a container. Okay. So here you can see the API version, the API that the version of API server. Okay. So it's version 1, and here we can see the kind. Okay. So we need to mention what type of kind that we going to deploy. So the kind here you can see it's a pod. So what will happen? It will create a pod. So coming to metadata, okay, we need to provide the names for the application or the deployment. So here we use Nginx app. So similar way, we adding a label for our application or the port. So the label is Nginx. Okay, these all the things comes under the metadata. Metadata comes under the metadata. We need to mention the names, labels, and these things. Okay. Then the specification. Okay, under the spec, you can see here container. So under container name. So here we need to mention the image. Image container image name, that is Nginx container. So under image, we need to specify the image name. See Nginx latest. So this is actually a Docker image that is under the Nginx. So whenever we are running this YAML file, what will happen? This file goes to first is create a pod with the name Nginx, the label, the name Nginx app and the label Nginx. Then coming to the container part, it will go to the internet and searching for the image that is called Nginx latest. So it will download or it will pull the image from the Docker Hub and run the application within our container. And the port number here mentioned, the port number is 80. So this is a small YAML file for running a Nginx web server. Got it?
So how did you reach to this screen? Like this file, how did you open this?
Sorry?
You created this file or like how?
No. I didn't get you actually. Created?
No, I just want to know how did you reach to this screen? Because we missed that part.
Is it an inbuilt file or did you write this
Create it
file?
or like
No.
yeah.
This is defined file, inbuilt file.
How do we get to this screen?
This is my Visual Studio Code. This is a Visual Studio Code for uh, deploying applications. So we can use any code editor like any Studio, or we can use PowerShell or command line tool, any tool that we can use. So this is a simple tool that we can integrate with our applications or the services. So here we can create the file, then we can take the terminal. So under here we can take the terminal. See. So here we can using the command like kubectl apply the above file. Then what will happen? This file will go to the Kubernetes and deploy the application that we specified here. Got it. Any doubt?
To use this Visual Studio Code, do we have to have any theory text which how to get into that? Do we have anything written about it? How
For
do we
the
first get started in this?
You have to download it, I guess. You have to download it, that one.
Okay.
Just go to Google and download. It's easy.
Okay.
Always check on Google how, like, this is just the code or the text is just written, typed up, and Visual Studio is one editor. You could use it. If you like some other editor better, you could use some other editor. But a lot of people use Visual Studio. But you don't
Okay.
have to. You can use something else.
Okay, thanks.
So anyone have any doubt?
No doubt.
So we can wind up, right? So coming tomorrow, we are going to configuring this Kubernetes cluster in AWS. So after that, we will deploy some sample application and we expose the application so we can access the application through our web browser. Okay. Is that fine?
Sure.
Yeah, sir. Sir, I have a request. Can you please share the videos of Docker
I will share.
classes?
I sent it to the concerned person, but I didn't get that link. So after that, I will share. Okay.
Yeah,
I
because
put,
I think we were having two classes of Docker, and I think the last one is missing. I don't know, like, how come this is saying day 12, and it is a Linux? Because I think the last classes we were having for Docker only.
that is 13 and 14, I think.
Yeah, so 13, 14 I'm looking for, but we have received only like
Yeah,
12
yes.
till day 12.
I will push her today. Okay.
Okay. And sir, one more thing, sir. I have missed this class due to my connectivity issue. So, is there any way with which I can go through the recap or get the recap or something like that? Or just watch some video randomly online?
For the Kubernetes, right?
Yeah, I don't know how much I have missed.
I
Yeah.
will share. I will share the documentation and share this video. Okay, just go through, or else I will explain the next class as well. Okay, just done.
Just to make, yeah, maybe just a little bit, like 2-3
Sure,
minutes
sure,
recap.
sure.
Yeah. Thank you, sir. Thank you so much.
Sir, can you apply the classes link in Sheets? Then we can
Uh,
find it easily.
yes, I will share. I will share. I think you can access the there is a cloud Excel that sheet there. Mm, I think you need to check with your HR about that. You have the permission to view that data.
Yes, sir. Yes, sir. We have. She shared some previously one spreadsheet.
I think she need to
Batch
update.
1 and batch 2
Yeah.
is
I think
there. Batch
she,
3.
yes. She need to update batch 3, I think. I will update her.
Okay, sir. Yeah, sure, sir.
Okay. So anyone have any doubt?
Sir, it's like my personal issue which I'm going through. I don't know, like maybe you can help it with it or not. Just for your suggestion, I need your suggestion basically. I don't know what's happening with my AWS account. The connection is like it's not letting me stay connected. Like every 2 minutes, it's disconnecting. But like my other like YouTube and other things are working fine. So there is no issue with my internet. Is it something like AWS with AWS only?
Or it will take 2 minutes, right?
Yeah,
After
every
two
two
minutes,
minutes
it's
it's
go to
disconnecting. Like for the
disconnecting
whole
sense
day,
of we need to sign up again, right?
sir, I did all that stuff like resetting everything, restarting, then restart my Wi-Fi and my machine. I change my machine, but still the same thing is happening every 2 minutes. By the time I put my initials, like credentials there, and I'm expecting the screen to pop up, but it disconnect,
Can
saying
you
like
show,
internet
can you
issue.
show me the scenario?
I don't know if it happens here
If you
or.
take screenshots and you send it to the AWS has a tech support, they'll respond to you fast.
Yeah, I sent that they have some form over there, so I just submit one query over there. But they said like they will take another 24 hours to resolve this. I mean, to respond, not resolve, to
Did
respond.
you take screenshots?
No, it's happening. I think I should try now. I'll show you what's happening.
Sure.
take screenshots, so it's easier to in describing sometimes. They do get back to you. They say within 24 hours, but they will get back to you in 24 hours.
Okay. I'm just trying to sign in. Let me share my screen. Mm,
Are you sharing or?
Sir, I'm just trying to do something like or trying to open it, and so that I can share the final screen what's going on. Like, for some reason it's working now. I don't know why, but for the whole day today it was not working, and it was not with the this skill builder. It was with the this AWS console as well. But
Mhm.
now it looks like it's working fine. But here, if you can see, like after 2 minutes, every 2 minutes, it gets like disconnected.
Disconnect in the sense of like going to log out automatically. That's
It
that's
the page was not loading. Yeah, the page was not loading.
so if it happen again, okay, just to copy the entire URL and try it on incognito mode, okay.
To take the screenshot and then to show
No,
it
no,
to
no,
you, or like to
no,
report.
no, no. Just copy the URL, the
Okay,
URL and try the same in incognito mode. Like go to
incognito
the
mode.
incognito mode and try
Okay.
it there, okay.
Yeah. I should have tried that. Yeah, I didn't try that thing. Yeah. Okay, I changed my machine and this and that, like resetting everything, but it was like giving me issue. Since morning I wasn't able to work anything, so
Hmm.
it was like that bad. So
Good, good,
okay,
good.
anyways, we'll see how it works. Like, so
Okay.
yeah, sir, please do share the videos if you
Sure,
can,
sure,
huh?
sure, sure, sure.
Okay, thank you, sir. Thank you so much.
Anyone have a doubt? Otherwise, we can wind up the section. All are good, right?
Yes, sir. Thank you.
No doubt. Thank you for the class. Have a good night, everybody. Good morning.
Bye.
Bye.
Bye, everybody.
Bye bye.